when we're setting up a screening experiment, first thing we do is a denaturation optimization, and that means that we're looking at different temperatures, usually 4 different temperatures, to obtain the best conditions for the sample preparation. Usually that's something like 70–75% for an IgG, and there's always an optimum temperature that has determined before the project, and then all the samples can be run at the same temperature. So that's the first thing that you do, and once that is done, you are assessing the effect that the supernatant has on the assay, and this is necessary to find the optimal range for the assay, which means like what is the final concentration range of the IgG, which is optimal, and what kind of dilution is necessary for this. And here, in this example, we used 2 glycoforms of the same IgG that had different levels of afucosylation, and we ran the assay with samples diluted in mock supernatant, and then we diluted the samples in PBS, and you can see that in both settings the fucosylated sample shows a higher marker binding. That's what you would expect, higher than the afucosylated glycoform, which was something like 20% or so fucosylated, and the fucosylated, the fully fucosylated, had 100 or close to 100% fucosylation. And what you can see is that the assay in PBS shows a much higher delta between those 2 curves, which means that the discrimination power of the assay in PBS or in supernatant diluted in PBS is a lot higher. So as a rule of thumb, you would say that the more you can dilute the samples in a buffer like PBS, the better it will be for the discrimination power of the assay. So that's the one thing that you can derive from such an experiment. Second thing is that you can derive the IgG concentration range, which is optimal for such an assay. And you would say that here, anything from maybe 50 to 100, maybe 150 is a good range for this assay, in which we will have a real good separation between fucosylated and afucosylated samples. So when we use that in a screening scenario, and this is an example from screening on the 24 deep well stage, what we do is we have the samples, we know their concentration, and all the samples are diluted by the same factor and buffer. And then we perform the assay, and what we get is the fucose marker binding in percent. And at the same time, you have the titer information for all the samples. And in order to find now the degree of fucosylation, you do a normalization for titer. So now the higher bars, the high bars show you the highly fucosylated samples, and of course then the low ones, the samples with a low degree of fucosylation. And as a next step, you would do a ranking for the fucosylation, which allows you then to select the clones which are in the range that you would like to have in the clones that you are selecting and moving on to the next stage. So of course it would be good, or if one had at least one reference sample in that experiment with a known degree of afucosylation, for example, this one, and then you would know that every clone or sample in the vicinity would be at a rather similar level of fucosylation. And of course, if you had more than that one reference sample, you could really have more kind of landmarks in this graph to have some kind of calibration if necessary. Okay, and that's what I wanted to show you. I hope I could show you that we have this PA201 assay, which allows you to do very fast afucosylation screenings, which means that hundreds of clones can be measured on a day, and you would have to plan, I would say, maybe a little more than half a day to do the setup experiments, this denaturation optimization step, and this dilution protocol development, but then you're ready to go. These assays work on standard equipment in the lab, plate readers, shakers, imagers, etc. So they can really be nicely implemented in CLD labs and hopefully accelerate the clone selection and finally the projects. So thank you very much for your attention, and I'm happy to answer any questions.
Thank you, Sebastian. This is Altaf. I had a question.
Sure.
You restricted your cell line development workflows to only with the 24 deep well platform. Have you, in other words, anything below 50 microgram per mil for a cell line development sample is going to be hard to detect? Is that correct? An assessment.
Well, the 50 microgram per mil is the concentration that you should be able to get to after the dilution in the buffer. So in a 24 deep well, of course, the concentration is so high, you can use maybe 1 to 20 or whatever, a dilution to get to that level. But you should be able to do this in 96 deep well as well. The titers must be high enough and at that stage.
Yeah, I think you answered my question. Thank you.
Yeah.
Would use of fluorescent lectins improve the sensitivity of the tool?
We're using fluorescent lectins. I'm not sure I get your question, Altaf.
No, you answered it.
Yeah.
I was trying to see how we could push down the sensitivity below 50 microgram per mil for platforms that are static in early stages of cell line development.
I mean, static. Of course, yeah. There it may become, yeah. You get it. you will have a problem with sensitivity, yeah. But I'm not sure how much sense it would make to look at static. I don't know, but knowing that already titer is not very or must not be very indicative of the scaling up from static cultures, I wouldn't be sure that glycan screening makes a lot of sense in static cultures, but I may be wrong. I don't know.
Yeah, the scale up happens predictably. The protein concentration is surely low. Yeah. What I'm asking and trying to get at is how early can the PAIA kit be put in place?
Yeah, I mean,
right.
I think one thing, yeah, I mean, if you're really looking at low levels of afucosylation, and you don't see any binding, you can be sure that there's very low fucosylation in there. I mean, also in static cultures also, of course, good clones should be in the range of 50 to 100, right? So
yeah, typically
clones
maybe at the 6-well stages. Yeah.
Yeah.
No, thank you. Appreciate your help.
Yeah.
We will stay on the line for a couple more minutes here and let you think about if you have any other questions while we're on the line with Sebastian. We also, we have a recording of this presentation, which will be available for download in the future. But in the meantime, we'll let you think about any questions and we'll hang on for a minute or two.
Can these slides be shared?
Yes, sure.
Thank you.
So just shoot an email to Chris, right?
That is correct.
Okay.
We have all of your email addresses, so we'll be following up with you anyway for some feedback on the presentation. Give it another 30 seconds here. Okay, at this point, we would like to thank everybody for sharing part of your day with us and listening to this presentation by Sebastian from PAIA, and we'll be following up with an email. Thanks for taking the time, and the presentation will be available for download in the near future. And I hope everybody has a great day. Thank you for your time, Sebastian, and we will talk to everybody soon.
You're welcome. Yeah, thanks everyone. Bye-bye.
Goodbye.